In this chapter, we're going to learn about metals. But if we look back at some of the chapters that we have done before, we have in fact, learned quite a lot about metals. So before we go into the new stuff, let us revise what we have learned about metals. The first chapter that we encountered metals is in chemical bonding. We learned about metallic bonding. So if we were to zoom in to a piece of metal until we reach the particle level, we will see that the metal atoms are regularly arranged in a very orderly fashion. Okay, so this orderly repeating arrangement is called a lattice. Alright, and in the metallic lattice, the metals actually lose their valence electrons. So they do not hold on to their valence electrons, but the valence electrons are moving around in the lattice. We call them a sea of delocalized electrons. Okay, so since the electrons are not associated with any one atom, so the metal atoms carry a positive charge. Alright, so if we zoom into a piece of metal until the atomic or the particle level, this is what we see. And this structure, we call it a giant metallic structure or giant metallic lattice structure. Okay, so what is it that holds your atoms together? What is it that holds the particles together to form the metal? Is the attraction between plus and minus again. Remember, in science, we opposite charges attract. So this negative charge, actually there's an attraction between the negative and positive charges. This attraction, the attraction between plus and minus, we have learned previously, is known as electrostatic, okay, forces of attraction. So the electrostatic forces of attraction between the metal cations and the sea of delocalized electrons. Alright, this is known as your metallic bonding or your metallic bonds. Okay, we have also previously learned that this metallic bonds or this attraction is very strong. So a lot of energy is required to overcome this attraction. Therefore, metals have high melting point and boiling point. Alright, we also learned that since there is a sea of delocalized electrons, meaning the negative charge can move around freely, therefore they can act as charge carriers. So metals are good conductors of electricity. The next thing that we learn about metals is that they are malleable and ductile. In case you have forgotten, malleable simply means that it can be hammered into different shapes. Ductile means that it can be pulled or drawn into wires. Now, why is that so? Why are metals malleable and ductile? It's because of the sea of delocalized electrons. Now, one way to imagine a giant metallic structure is that the sea of delocalized electrons are like glue. Alright, are like glue. They are always surrounding the metal cations. Now, when a metal is hammered, the position of your metal cations may change. Alright, but is the attraction, is the electrostatic forces of attraction still present? The answer is yes, because your electrons are still surrounding the metal cations. Alright, so as a result, since the electrostatic forces of attraction are not disrupted when the metal cations are displaced from their original position, the structure doesn't break down. It is simply deformed. That is why metals are malleable and ductile. Now this slide summarizes whatever that I've just recapped in the last slide. So importantly, we need to know the properties of metals, and we need to be able to explain them using structure and bonding within the metal. Now the other chapter where we got to learn about metals is in periodic table, where we studied the group 1 elements. However, group 1 metals, they are not representative of all metals. They have rather unique properties. For example, group 1 metals have unusually low melting point, boiling points compared to other metals. They have unusually low densities compared to other metals. But one thing that is common is that when you compare group 1 metals to other pure metals, they are actually pretty soft. We have seen that we can actually use a knife to cut sodium. So that is why pure metals are rarely used on their own, because they are not very strong. So in the next part, we're going to look at what can we do to make metals stronger, and why is it that they become stronger by doing so. One way to make metals stronger is to form an alloy. Now the term alloy is not new. We have encountered this in element, compounds and mixtures. If you can remember, alloys represents a mixture. Alright, it's a mixture of a metal with one or more other elements. We have also learned then that there are 3 alloys that we need to know in the syllabus. Steel, which is iron plus carbon. Brass, which is copper plus zinc. And bronze, which is copper plus tin. So these are the 3 alloys that we need to learn in the syllabus, meaning we need to know what is the mixture of elements that forms that alloy. So as mentioned, forming an alloy can make the metal stronger. That is the main or most important point that we need to remember. Other than that, forming an alloy have other uses as well. For example, it can lower the melting point of the metals. Now why is that important? Because in some applications we need to melt the metal in order to reshape the metal. So if by adding some impurities to form an alloy, if you can recall, adding impurities will lower the melting point of a substance. So if the melting point is lowered, then we can use a lower temperature, lower operating temperature to melt the metal. And lower operating temperature simply means that we don't have to apply so much heat. It also means that we can save money. Next, by forming an alloy, we can also make the metals more resistant to corrosion. For example, your stainless steel. Okay, in stainless steel, other than iron and carbon, we also add a bit of chromium. Okay, so later on we will see how adding chromium can make steel more resistant to corrosion, can make steel more resistant to rusting. And lastly, it can improve the appearance of metals. It can make it shinier. For example, certain jewelry, they actually add nickel to make it whiter, to make it brighter. However, the most important point that we need to remember is point number 1, and therefore we need to learn the explanation as to why forming an alloy makes the metal harder and stronger. Now in this slide, there are 2 diagrams. The diagram on the left shows how the particles are arranged in a pure metal. The diagram on the right shows how the particles are arranged in an alloy, in this case steel. Okay, so each particle over here represents an atom of iron, and then you see the small little particles on the right, they represent atoms of carbon. So now imagine this scenario. If I were to apply a force to this layer of atoms, what would happen? If you can imagine them as little stacks of balls, if I were to apply a force, the layers will actually slide easily. In this case, in the case of a pure metal. Okay, why? Because the atoms are all of the same size. They are arranged in a regular manner. So when I apply a force, the layers can easily slide over one another. How about the case of an alloy then? If you take a look at an alloy, there are little atoms in the way. Okay? So the atoms, the impurity atoms, are actually of a different size compared to your metal atom. And what happens to that is that they will disrupt the orderly arrangement in the metal. So now if I were to apply a force to one of the layer, you will find that this impurity atoms, they will actually block the sliding of the layers. So that is why forming an alloy will make the metal harder. Now it's more obvious if I add an impurity atom which is larger in size than iron. For example, if I add a very big impurity atom, now my regular arrangement is disrupted even more. Okay, so in this case, again, when I apply a force, the layers, because the orderly arrangement is being disrupted, the layer can no longer slide as easily. So these are the three important points that you need to write down when explaining why metals, pure metals, are soft and why alloys are hard. So we'll look at one case at a time. Why are pure metals soft? Because the atoms are of the same size. They are packed in an orderly arrangement. And what happens when you have an orderly arrangement is that when a force is applied, the layers of atoms will easily slide over one another. On forming an alloy, the impurity atoms, the atoms that are being added, have a different size. So what happens is that it will disrupt the orderly arrangement of the atoms in the structure. And when a force is applied, now your layers of atoms can no longer slide easily. Alright, this is a very common question that you'll get in O-levels. So to get the full marks, I would recommend that you write all 3 points. For example, if you are asked to write why is it that the forming of an alloy makes a metal stronger, please include all 3 points as shown. The other thing is this, students tend to say that when a force is applied, the atoms cannot slide easily over one another. That is not correct. So we need you to recognize that it's the layers of atoms that are sliding over one another.